Hello everyone, welcome to my presentation. Now I'm going to talk about our paper. In this paper, we propose a lower framework to reduce neighbor bias, which consists of two phases, initialization and refinement. In the initialization phase, we propose a masked timestamp prediction, also called MTP module, to reduce the dependency on annotated frames and use contextual information to predict their action categories. In refinement phase, we propose a center-oriented timestamp expansion, also called CTE module, to progressively expand pseudo timestamp group that can contain more semantic information and use pseudo labels to refine the model. Our framework not only outperforms the state-of-art of TS task method, but also achieve competitive results on fully supervised method on 3 benchmark datasets. First, I will give you some background and motivation for our research problem. Temporal action segmentation is a task that aims to segment and recognize action in untrained videos. For example, in this video of salad preparation, we want to identify different actions such as cutting tomatoes, peeling cucumbers, and mixing ingredients. Timestamp supervised temporal action segmentation only requires a single annotated frame for each action segment. This reduced annotation cost significantly, but also introduces a new challenge: how to learn the semantics of the entire action segments from the sparse single-frame annotations. Focus bias means that the model tends to focus on frames similar to the annotated frames. For example, in this figure, we can see that the model prefers to predict frames similar to the annotated timestamp, leading to the incorrectly identifying dissimilar frames within the segment and similar frames outside of the segment. Second is the representation bias, which means that single frame fails to represent the entire action segment for complex actions. Now I will illustrate the overall architecture of the DTS task and explain the main components. In the initialization phase, we introduce our method MTP module to reduce focus bias. The idea of MTP is to mask the input features of temporal timestamps and use contextual information to predict their action categories. The process of MTP module is shown in this figure. Given the input video features, we mask the features of annotated timestamps by a shared learnable token. Then we feed the masked features to our segmentation model and compute the cross-entropy loss as the annotated frames. After the first stage, we get initialization parameters of the segmentation model. Now I will introduce our method to reduce representation bias in refinement phase. The idea of CTE is to expand pseudo timestamp groups that contain more semantic information than single timestamps. This can help the module to overcome the limitation of expressiveness of single-frame timestamp and generate better pseudo labels. And then we refine the model with pseudo labels and propose segment conference loss. The process of CTE module is shown in this figure. Given the output features of the final decode and the current timestamp groups, we estimate the boundaries of pseudo labels. Then we choose the center frame of each segment in the pseudo labels and as pseudo timestamps, and update the timestamp groups. We repeated this process for several iterations to progressively expand pseudo timestamp groups. Finally, we refine the model with pseudo labels and the segment confidence loss. CTE loss can reduce representation bias by capturing more semantic rich motion representations of action segments. By expanding pseudo timestamp groups, we can include more frames that have different semantic information within the same segment. This can improve the quality of the pseudo labels and the model prediction. In the next slide, I will show you some quantitative results and analysis of our framework. We use the standard evaluation metrics, including frame level accuracy, segmental edit distance, and the segmental F1 scores. In Table 8, we compared our method with other timestamp supervised methods on 3 data sets. We can see that our method outperforms other methods significantly, especially on F1 at 50. This shows that our method can effectively reduce neighbor bias and generates more accurate and coherent action segmentation results. Moreover, our method can also compete with fully supervised methods. This indicates that our method can make full use of the information from timestamp annotations and unneighbored frames. Finally, I will show you some qualitative results and analysis of our framework. First is MTP module. In fact, MTP can reduce focus bias by propagating timestamp supervision information to the contextual frames of the timestamps. For example, in this figure, we can see that naive only correctly identifies frames close to the timestamp, which are also similar frames to annotated frames. MTP reduces this bias by directing the model to capture contextual information, but the boundaries of the segments are not accurate. Adding naive after MTP module can generate better predictions as the model explores semantic information with annotated timestamps and the context of annotated frames. And then the CTE module's approach aims to reduce the representation bias of the model by expanding the pseudo timestamp groups that contains more semantic information of action segmentation. We visualize the generated pseudo labels as shown in slide below. We show the process of updating steps of CTE in step 1. These pseudo timestamp groups obtain rich action representations for action segments. That's all. Thank you for your watching.